Rightio. G'day. I thought we'd start off this series of videos which are related around studying for your exams. If you have a look here, I've decided to start with our linear unit, and you'll notice that for me to go and start studying, I've started at our assessment piece or our test. Now, you should, of course, have this already in your portfolio. And what I thought I'd do is just run through each of the particular columns and why questions are what they're aware and what are the actual techniques in which to do it. So this one's going to start by looking at probably the beginning and the approaching standard. And then I'm going to make a separate video on that and then probably a separate on above and well above. So we're just going to have a look at the beginning and approaching in this particular video. So we have a look here. Basically, linear algebra is about trying to find out what this letter is. Now, it's something, we don't know what it is, plus 4 equals 10. Many people out there will probably be able to go, well, okay, well, that's 6. 6 plus 4 equals 10. And I'd say, well, there you go. You have solved this particular question via a method that we would call inspections. In other words, I looked at the question and I was able to do it. Now, while that's fine for something like here, what happens when we get up to something like this, for instance, which is a little bit more complex, a little bit harder for us to just sit there and look at and inspect it. So what we need to do, I suppose, is work out some kind of method in how we're going to actually deal with these things. Now, many people would have thought, well, probably what I actually did is I said 4, and then I took that 4 away from 10, and that gave me 6. And this is kind of basically the techniques that we're going to use. So we've got a plus 4 here. So we're going to take 4. We're going to do the opposite of plus. Now I'm going to write this up. The opposite of plus, of course, is take. And the opposite of timesing something is, of course, to divide it. So because we've got a plus 4 here, we're going to take 4 away, removing it from that side. But we've also got to do the same on the other side. So x is going to be equal to 10 take away 4. And that, of course, means that x is equal to 6, which we already knew. So we did the opposite of this particular operation to find out our answer to x. So if we come and have a look here, we've got x take away 2. So the opposite of taking something is, of course, to add it. So we're going to add 2 on this side, and we're going to add 2 on that side, and that means that x is going to be equal to 8 plus 2, which of course gives us that x is equal to 10. And if we think about it, if we had 10 and we took away 2, we would get 8. So that's another important thing to remember with linear, is that you can always substitute your answer, so in other words, making this x a 10 that we found, take away 2 equals 8, good, so I could check that my answer was correct. Now, of course, if we look at probably the last 2 questions here, although there are some more, we can see here that we've got 2x is equal to 10. Well, what does 2x mean? Well, 2x means 2 lots of x, or 2 times x. Now, we don't put the times in there, obviously, because we could get confused that there's 2 x's, but it says 2 times whatever x is equal to 10. So this is the first time that we've seen a times question. So 2 times x is equal to 10. So what are we going to do with this times? Well, of course, we know that the opposite of timesing is to divide this particular thing. So I'm going to divide this by 2, which means, of course, once I do it on one side of my equal sign, I need to do it on the other. I'm going to get 10 divided by 2, and of course, that gives me 5. Now, check our answer. 2 times 5, well, yes, that does equal 10. So I'm fairly sure that, of course, x is equal to 5. Now, the last question, I'm just going to get rid of this one because I'm going to put a new one in. And then I'm going to go x divided by 2 is equal to 10. Now, of course, remember, I'm using this line here as divide. So we need to be able to do the opposite of dividing. So the opposite of dividing is to times. So we're going to times by 2, which means we also need to do the exact same thing to keep it equal on the other side. And so 2 divided by 2 is 1. 1 times x is x. And then, of course, we've got 10 times 2 is 20. Once again, checking, we put 20 back into this. So 20 divided by 2 is, in fact, 10. So we've managed to put our answer back in, and we've managed to check it. Now, we would call this single-step equations. And they're called single-step equations because, of course, we've only had to do one step. We either had to do the opposite of plus, do the opposite of take, 2 times x or x divided by 2. Now, funnily enough, these questions are in these questions. Where really, once we leave this section, it's just an idea about what order we actually have to do these questions in. So what I mean by that is let's have a look at this top question here, which is 2x plus 10 is equal to 20. So I know that because it's a plus 10, according to this, I'm going to have to do the opposite. I'm going to have to take 10. And this is 2 times x, if you remember from down here, 2 times x. So I'm going to have to divide by 2. But the only problem is, which one do I do first? Do I divide by 2 or do I take the 10? Now, the rule I like to use is furthest away from the x, I'm going to do first. So if we look at our little arrows, the 10 is further away from the x than the 2, so I'm going to do the 10 first. So instead of adding 10, I'm going to do the opposite, and I'm going to take 10. Now, on this side, I'm going to do this side first. That would leave me with 2x equals, now I've taken 10 from this side, but I haven't done it from this side, and I need to. I need to be equal or balanced about what I do on either side of these particular equations. So I'm going to go 20, take 10, which is going to give me 10. And then, of course, I know that there should be a little times in here. So I'm going to do the opposite. I'm going to divide by 2. And so x is going to be equal to 10 divided by 2, which is 5. Now, I can check this. I can go, well, 2 times 5 is 10, plus another 10 gives me 20. So I'm pretty confident, in fact, I'm sure, that that is my particular answer for that question. Now, that's in there because this is what we call a multi-step equation. Multi-step, because we had to do 2 equation. Now, the next is what happens when all of a sudden, what's different between this question and everyone else is that we've got these x's on both sides. Now, a lot of kids go, well, what do we do now? We've got 2 x's. Well, we can move x's as simply as we can move numbers or letters, as we've been doing. So by taking this 4, we moved it over to the other side. So here, what I'm actually going to do is I'm going to start off this question by taking 6x from this side, and I'm going to take 6x from this side. And that means that 6x takes 6x, leaves me with the number 14 on this side. And then 8x's take away 6x's, leaves me with 2x, plus 4 on this side. And the great thing about this is I've managed straight away to get rid of the 2 x's. I've only got 1 x now. And we notice that this question here is very similar to the question that we just did a minute ago. So we've got a 2x and a plus 4. I'm once again going to check which one is furthest away from the x. Now, most people would say reverse order of operations, but then it's around these questions here that I'm reluctant to say that, and we'll get to that when we look at the @standard video. So what I'm going to do here is I'm going to take 4, and I'm going to take 4. So we get 2x is equal to, well, 14 take 4, of course, is 10. And then we've had this question before. We know that 2 times x is in there. So we're going to do the opposite. We're going to divide. We're going to divide the 10 by 2, and that's going to get us to 4. So x's on both sides, no great problem, because of course we can just move them to either side. We can just get rid of the x's using the method that we've done to remove these numbers from all of these particular equations. Now, the only other thing that I think I want to talk about in the approaching section is if I just bring in this one here. Okay, and we have a look. It's probably something around this that I want to address. I just want to have a look at this particular question because this requires us to use a thing called the distributive law. If you remember in maths, this 3 and this bracket means the bracket's there because it wants us to times everything in that bracket by 3. Okay, and sometimes in maths we have to do this, and so we have to show people because, of course, if we write it as 3 times 2x plus 4, some people would think, oh, well, I just need to times that and then add 4 to it. But no, this tells us that we need to go 3 times 2x, which of course is 6 lots of x, and then 3 times positive 4, which gives us a positive 12. Positive 3 times positive 4 gives us 12, and we get 36. And you can see that it would be a lot different because if we'd done it just this way, we would have got 6x plus 4, and that means, of course, that we would have got our question wrong because it actually wants us to times everything in this bracket by 3. and that's why the bracket's there. So we have a look here. Once again, we've got our 6x plus 12. I'm going to look at the one that is furthest from the x. Well, it's the 12 in this case. It's a plus 12. So hopefully you can do the opposite by taking 12 from both sides. Now, 36 take 12 is 24. 6x is equal to 24. So now what do we do? Well, of course, we would divide this by 6 because it's 6 times x. And we would divide this by 6, and that would give us that x is going to be equal to the number 4. So basically, that's probably it for our beginning and approaching standard. Stay tuned because the next video, of course, is going to be looking at the at. So thanks for listening, and I'll see you later.